Everyone. So today we'll be discussing about a problem from Nbpho of past year paper question, and this question is based on center of mass and collisions. So let's get started. The question says there are n plus one elastic balls dropped on the floor, dropped so that they are exactly one above the other, with a small gap between them. The bottom ball has mass m0, the above one has mass fm0, and so on, where f is less than 1. At the moment when the bottom ball touches the ground, all the balls are moving with speed v. Okay. After the collision between the two bottommost ball, what will be the speed of v1 of the second ball from the bottom? Second is, what is the speed of the topmost ball vn after all collisions? And third is, how many times higher would the ball fly compared to the initial drop height h? Take a photo. For now, I will be solving question number 2 at first so that I can get the answers of question number 1 and question number 3 automatically. Question number 2 says that what is the speed of the topmost ball after its collision? At first, I need to derive the value of the speed of the ith ball after the collision with this I minus 1th ball. Suppose, or you can take I plus 1th ball, and here is ith ball. Now you might have heard of any famous experiment like here's a small ball, suppose it be a Costco ball, and here's a football. Both are dropped simultaneously on the floor. What will happen that if another similar Costco ball is dropped at a similar height, it will rebound and reach another again a height either less than the height which from which it has been dropped, or if the floor is very elastic and it's all idealistic conditions, then it will exactly reach its height again. But in the second case where it's a Costco ball and a football, what will happen is the football will rebound and the Costco ball will fly higher than the edge, right? So this is the famous thing about the experiment. The same experiment is conducted in the above problem. The same thing is happening here. Now I assume that first m naught has collided with velocity v, then it will rebound with velocity v as it's an elastic collision. Now fm naught is also moving in the opposite direction to m naught, so it will also collide with same velocity v, but they will have some different velocities. It will be some v1 dash and it will be v2. So I assume that after several collisions, ith ball has gained a velocity of vi, and still now the I plus 1 is moving with velocity v as stated in the problem, since the gap between each of them is negligible. Okay. Now after collision I am taking the case that suppose the velocity of this I plus 1th ball be vi plus 1 and the ith ball be vi. This is the second case and this is the first case. First we'll write the equation for elastic collision, that is v plus vi is equal to, this will be vi dash, well pardon me, is equal to vi plus 1 minus vi dash. From here you will get vi dash is equal to vi plus 1 minus v minus vi. This is first equation. Second equation will be about momentum conservation, that is what will be the mass of the ith ball? It will be f to the power I minus 1 into m, and I plus 1 will be f to the power I into m. So f to the power I minus 1 into m into vi minus f to the power I m into v is equal to f to the power I v I plus 1 plus f to the power I minus 1 v dash I into m. Dividing both sides by m into f to the power I minus 1, we will get vi minus Fv is equal to Fvi plus 1 plus Vi dash. And we already derived Vi dash to be Vi plus 1 minus V minus Vi. Okay. Now rearranging, we'll get Vi plus 1 is equals to 2 by 1 plus F into Vi plus V into 1 minus F upon 1 plus F. So this is the recurrence relation we'll be getting regarding the velocities of the ball just after the collision with its previous ball, with the ball beneath it. We are also given a mathematical tool that for the sequence a0 equal to 1 and ak plus 1 is equal to alpha k, sorry, ak into alpha plus beta, has general term of an is equal to a to alpha to the power n plus beta into alpha to the power n minus 1 upon alpha minus 1. Well, this expression looks to me a little doubtful because it must involve another term of v naught, means a0 also, I guess, as per me. So the solution to this equation will be vi vi is equal to vi is equal to v into 2 by 1 plus f whole to the power n. I don't know why they didn't write it like an is equal to alpha k alpha to the power n into a0 plus 1 minus alpha to the power n upon 1 minus alpha into beta. I think there will be another a naught because a naught is given as 1, so they neglected it possibly, but I'm considering it here. Or you can also say that assume an to be vi plus 1 by v, right? So just divide it by v. Here v cancels, and we will get vi by v is equals to 2 by 1 plus f whole to the power I plus v into 1 minus f upon 1 plus f into 2 by 1 plus f whole to the power n minus 1 upon 2 by 1 plus f minus 1. Here there will be a v because I already cancelled a v. So I will get final result as 2 into 2 by 1 plus f whole to the power I minus 1 into v is equals to vi. So we got the answer of second problem. To verify, we can do one thing, that v0 v1 one minute v0 is equals to v1 is equal to 3 minus f by 1 plus f. So there is some, seems to be some problem, because it should be I plus 1, it should be I plus 1, so I minus 1 I mean, and then the equation is perfect. Or you can say that the bottommost point of the ball corresponds I equal to 0, then the above one corresponds I equal to 1, then the another corresponds I equal to 2, and so on. So the velocity of nth ball will be 2 into 1 by 1 plus f whole to the power n minus 1 minus 1 into v. So that will be give my velocity of the nth ball after rebounding, after all the complete collisions and so on. Well, in this problem, the last step was more or less about adjustments, because how we'll set the constants and all those. Basically, to find the general value of Vn, we can also assume it to be something like V2, like a alpha to the power n plus beta form, and then we'll derive it for n equals to 0 and n equal to 1. For n equal to 0 it would be easy, that is the bottommost one, and for n equal to 1 we'll need to do some more manipulation to find the velocity of the ball just above the bottommost ball. Then again, finding constants a and beta, or you can take c and gamma, anything you want. then it will be a little tedious calculation. But yeah, it or we know that in exam we got a little time, so we can do all of those such things. So hope you enjoyed it. Rest of the problems is just you can say corollary of the second part. Okay, thank you and have a nice day.